Welcome. Let's understand the idea of complex numbers. Let's start by considering the equation x squared plus 1, and let's try to find the solutions for this equation. Well, we should start by setting our equation equals to 0. Let's subtract 1 to both sides. Now we're going to have x squared equals to negative 1. And to leave the x by itself, we need to take the square root on the left and the right. So now our solution is x squared equals plus or minus the square root of negative 1. But when we only consider real numbers, this expression of the square root of negative 1, it does not make any sense. Can you think of two numbers that if you multiply themselves is equivalent to the inside of the square root, which is negative 1? There are none. So does this mean that this equation has no solutions? Well, maybe we can find its solutions by plotting this equation. When we graph the equation x squared plus 1, we're going to have a parabola whose y-intercept is at the value of 1. And because the x squared is positive, we're going to be facing up. Now, when we graph this function, also notice that we're not intersecting the x-axis anywhere in this graph. So have we confirmed that this equation has no solutions? But this does not make any sense because our equation is of the second degree. Well, by the fundamental theorem of algebra, we are expected to have two solutions. But where are they? Well, we are just looking at the wrong plane. Like here we have a graph of x squared plus 1. And notice that when we introduce a new plane, our parabola, it's changing dimension. And when we introduce this new plane, notice that now our parabola, it is equivalent to 0 at two different locations. We can say that this parabola, it does have two solutions. We were just looking at the wrong plane. So when we introduce our new plane, notice that our graph is intersecting this plane at two locations. This is where we're going to find the two solutions that we were expecting. The first one being at this intersection, and the second one being at this intersection. And to properly interact with this new plane, we need to introduce a new set of numbers. And we're going to define them as imaginary numbers. The expression of the square root of negative 1, it is going to be equivalent to one of those imaginary numbers. Here, this is an I, or imaginary. So from this point forward, now we can work with two different kinds of numbers. The real numbers, which is the ones that you are familiar with. Those values in the number line from negative infinity to positive infinity, and the imaginary numbers, which are based on the expression of the square root of negative 1 being equals to 1 unit or one imaginary number. But what would happen if we combine these two types of numbers, real numbers and imaginary numbers? Well, let's take a look into that. Now we are ready to define a complex number. A complex number, it is a number which has two parts. The first part, it is a real number. And the second part, it is an imaginary number. And the letter that we use to work with complex numbers, it is the letter of Z. The real part, we're going to use the letter of A. And the imaginary part, we're going to use the letter of B. Notice that this second part, B, has the I for imaginary next to it. This is an indicator that this is the imaginary part. And notice that the letter of A, which is the first part, it does not have an I right next to it. So that's an indicator that is just a real number. And I want to make it very clear that this I, it's not a variable. We cannot just plug in values to it. It is just a letter that we use to indicate that is a different kind of number. It is an imaginary number. Think of it as a label. We are labeling who is real and who is imaginary using this letter of I. Now let's put this idea into practice. Let's identify the real and the imaginary part of the following complex numbers. In example A, we have the complex number of 2 plus 3i's. Well, the real part is where we do not have an I right next to it. So the value of the real part in this complex number, it is of a value of 2. And the imaginary part, it is the value that we have right in front of the I, which in this case, it is of a value of just 3. Real parts do not have an I. Imaginary parts, they do have an I. Now, in example B, -4 plus 5i, that is one number, which is made out of 2 parts. Now let's identify each of those parts. The real part is the part that does not have an I on it. In this case, it holds a value of -4. The imaginary part, it is a part where we do have an I on it, which holds a value of 5. And when we take a look at example C, here we have one number, the complex number of 1 minus 7i, where we are emboxing in yellow, that is one number. But this number is made out of 2 parts. Let's identify each of those parts. The real part is the section that does not have an I, which in this case, we have a value of 1. The imaginary, it is the part that has the I right next to it, which in this case, it is of a value of -7. Hello. If you would like to continue learning about mathematics, you can check out the videos on the left.